Let's start with the next question in Young's modulus. Okay, the question is, a copper wire of length 2.2 meter and a steel wire of length 1.6 meter, both of diameter 3 millimeter, are connected end to end. When stretched by a load, the net elongation is found to be 0.7 millimeter or 0.70 millimeter. Obtain the load applied. Now what is given to you? Young's modulus for copper is 1.1 into 10 to the power of 11 and that of steel is 2 into 10 to the power of 11 Newton per meter square. Correct? Now remember, the net elongation is given. So that is delta L1 plus delta L2. It is not just one thing. Alright, so keep that in mind and see what formula you are going to take. Are you going to talk about the ratio? Are you going to talk about the stress or the strain? First, understand what you are trying to calculate, apply the formula, and then you will get the correct answer. So go ahead, pause, try to solve the problem by your own. Let's write down what is given. Now you have two things, correct? One is copper and one is steel. So let's do it for both copper and steel. Now for copper, what is given for copper? So let's write down. So you have copper here and here you have steel. Correct? So let's write down. For copper, see the length of the copper is given to be 2.2 meter. Correct? So you have L1 is equal to 2.2 meter and that for steel is L2 is equal to 1.6 meter. Next, what else is given? The radius is given. R1 is equal to, diameter is 3, radius is 1.5 millimeter, so 10 to the power of minus 3 meter. Same way, R2 is also 1.5 into 10 to the power of minus 3 meter. The third parameter what they have given is the Young's modulus, correct? So Y1 is equal to 1.1 into 10 to the power of 11 Newton per meter square. Y2 is equal to 2 into 10 to the power of 11 Newton per meter square. These are the given information. Now let's try to calculate what we have to figure out. See, obtain the load applied. Now, load applied is basically the force, correct? Now, here, you cannot directly calculate the force. We have to come up with a certain, formula to figure it out. Let's talk about the stress. Because both of them, when you apply the load, both of them are being stretched, correct? And not only that, the net elongation they have given. Isn't it? From stress, you can calculate the force. From strain, you can calculate the elongation or the change in length, correct? Now, you have to compare stress and strain. Isn't it? Not compare. You will have to equate both of them. Some or the other way, some relation has to be there. Isn't it? Now, what you can take here is that, now guys, this is an important formula what you'll have to take. Okay, the tensile stress. Okay, the tensile stress S is equal to Young's modulus Y into the longitudinal strain. Okay, now remember, this is tensile stress. Okay, tensile stress is equal to the Y value, the Young's modulus, into the longitudinal strain. Alright, now let's look at the next one. How do we go about it? Now you will have to take it for both the cases. So for first case, that is for copper now. Okay, so what we are doing, so let's be very specific about it. So what you are doing is for copper. Okay, very, very specific. Now for copper, what are you doing? You have F divided by A is equal to, now guys, what is the formula? Y1 into delta L1 divided by L1. Isn't it? Now delta L1, you do not know that. L1, you know it. y1 you know it, and f divided by a. Correct? Now if you apply the same thing for steel, okay, same thing, that means what you're doing now is for steel, now you are applying the same thing. Correct? Now for this case you will have f by a is equal to y2 into delta L2 divided by L2. Correct? Now if you look at the LHS, both are one and the same. Let's equate the RHS and let's do the next part. Alright? What do we get when we equate them? You are going to get, see, what do we have? y1 into delta L1 by L1 is equal to y2 into delta L2 divided by L2. Correct? Take delta L1 by delta L2 ratio. So you have delta L1 divided by delta L2 is equal to L1 by L2 into y2 divided by y1. Okay, now carefully look into it. We are looking at just cross multiplying, that's all. Okay, we took a ratio and we are just cross multiplying, nothing more, nothing less. Very simple math. Alright, now what is there? L1, L2. So these two values are there. Now what is L1 value? L1 value you already know, 2.2 divided by, next one guys, you are looking at the value of L2, isn't it, which is 1.6 into next y2 value. Y2 is how much? 2 into 10 to the power of 11 divided by, the next value is 1.1 into 10 to the power of 11. 10 power 11, these two gets cancelled. This is twice. Correct? And next what you have? 4 divided by 1.6. 4 divided by 1.6. Isn't it? So, or you can also take it as 40 by 16. Isn't it? Or you can cancel off here itself. So, this becomes 4 divided by, so let's do the math here. 40 divided by 16, which is 10 divided by 4, or you can call this as 2.5. Correct? Now, what do we get from this? You are going to get delta L1 is 2.5 times delta L2. Correct? So, you got one particular relation here. Let's call this as equation number 1. Now, if you look at the question, see guys, if you look at this particular question, it says that net elongation is 0.7 mm. Net elongation. Isn't it? So what do you mean by net elongation here? Delta L1 plus delta L2 is equal to 0.7 into 10 to the power of minus 3 millimeter. Correct? Now substitute the value. What is delta L1? 2.5 times delta L2. Substitute that. So if you substitute 2.5 into delta L2 plus delta L2 is equal to 0.7 into 10 to the power of minus 3. Now, if you substitute this value and if you solve it, you have 1.25 delta L2, 0.7 into 10 to the power of minus 3. Correct? So, what is delta L1, delta L2 in this case? So, you are going to get delta L1 to be 0.5 millimeter and delta L2 as 0.2 millimeter. Or you can take in terms of 10 to the power of minus 3 into 0.5 or 10 to the power minus 3 into 0.2. Understood? So these are the values of delta L1, delta L2. Now you can substitute this back in the formula. F by A is equal to that y1 into delta L1 by L1. Substitute that there. Calculate the value of f. Okay, let's do this one now. You have f is equal to, or f by A is equal to y1 into delta L1 by L1, or f is equal to A into y1 delta L1 divided by L1. Now what is A pi r square? or you'll get F is equal to pi R1 square into Y1 into delta L1 divided by L1. You all know the formula, you all know the values now. Just substitution, that's it, nothing more than that. Okay, now pi value 22 by 7 into radius is 1.5 millimeter. 1.5 into 10 power minus 3 whole square into, now for Y1 you can take it for copper, correct? So if you are going to take it for copper, you will have 1.1 into 10 to the power of 11 Y1 into delta L1. See, delta L1 is 5 into 10 to the power of minus 4 divided by, and what is L1? It is 2.2 meter, correct? All the values are known, it's just the matter of calculation. Now once you start to calculate, you will get the answer as 1.77 into 10 to the power of 2, which you can approximate it as 1.8 into 10 to the power of 2 Newton. So around 1800 Newton of force is applied for the both combination of copper and steel. Alright, so answer is 1.8 into 10 to the power of 2 Newton.